Welcome back to the Caribou Data Science channel. Today is the Friday the 13th, 2020. It's the evening here in Central Ohio. I'm going to do an analysis. I'm going to call it a fact check analysis of this based on this email from the Our World in Data.org website. Data.org. That's an interesting website. Let's take a quick detour here because you might want to bookmark this website, particularly if you're looking for data. Okay. So here it is, ourworldindata.org. Research and data to make progress against the world's largest problems. And all their data sets are downloadable. Okay, you can look at an online plot. Then you have the option of downloading that data so you can work with it yourself. So I suggest you actually bookmark this website. Okay, but here's the title is, why do COVID-19 deaths in Sweden always appear to increase in the last 10 days? There are two ways that COVID-19 deaths can be represented over time: by the date of the death or the date on which the death is reported. In the data that we present on Our World in Data, deaths in Sweden are shown by date of deaths, while deaths in other countries are shown by data. So why is it different for Sweden and other countries? I mean, you can't have two different. You can't have two different sets of. You can't have. I just don't think it's a good idea to say, well, Sweden. We have a different rule for Sweden than we do for the rest of the world. Okay. Uh, I will mention also that Johns Hopkins University data set, which we'll be using here in one moment, also reports the date of the uh, the date of the death. Okay, because it says date, then it says confirmed for cases, then it says death. So I'm presuming that means confirmed the date of the death itself. Okay. The question is, we're going to compare two different data sets for Sweden. We're going to see. Well, you always, this is. I will make sure this is the second part of a two-part video series. All right. If you look you'll also see uh, some analysis of this data using uh, a LibreOffice Calc, a spreadsheet program. Okay, and you can use you can look at my code there. You can look at my spreadsheet, and I'll show you exactly how to analyze cases, how to do both a daily analysis of deaths as well as a 14-day moving average for that data. Hopefully that makes sense. So now we got this taken out of the way. Of course, we're looking for Sweden. So let's open up our fact check and let's come back over here. We got this. We're going to send Sweden 13. We're going to get rid of all this information down into here. And you're also going to notice I'm also going to be doing a lot of cutting and pasting here. Okay, that's another thing I want you to keep in mind. One additional thing here is I'm modifying the plot. Okay. Okay. So this time we are going to be using two different data sets. I'm probably going to use, I'll go ahead and include this anyway with that. The first thing we're going to do, we're going to pull in our data. And we're going to change our country is. So we can go ahead and run this first part here. I may not use it, but let's just go ahead and do this, okay? Uh, okay, let's do this. Okay, now let's run this. Let's make sure we got some data here. Okay, so this is the European Center for Disease Prevention and Control's database. Okay, so we got some data. Take a quick look here. Sweden, very good. Okay, so these are daily cases. Import. Import data from John Hopkins. Okay, okay. Let's solve. Let's do SE. JH. Okay, okay. Now, as you'll see here very briefly, that so let's put Ggplot2 BI. Okay, so first we're going to plot. Let's do a equals. Yes. Okay. Let's do a underscore underscore smooth comma x equals y equals s. Okay, okay. Let's try this. See if we can get a plot here. Oh, I don't know why this isn't working. Maybe it's because it goes over here. Okay. That's as far as. Okay. Now let's try. Okay, so now we have this is this is the lowest curve for daily cases for this by the call. Subtitle quotes control. Okay. Let's do one thing. Let's increase this a little bit by 1, 2. Okay. Save that. Okay. Now we get a little trickier because let's see if this even works. John Hopkins data has lowercase country. Okay. This is going to be date. Let's get rid of, we can leave cases there, but this is actually confirmed. And this is actually death. So let's see if this actually works now. Oh, okay. Okay, so now we got numbers here. Uh, let's take a look at it. Okay, there certainly are cases there in SC. I wonder if I misspelled this again down here. Oh, that's not. Okay, let's come back up here. There's something wrong up here. This is still DB, right? Let us do this. Let's see what happens when we do this. Okay, so let's do a quick summary here, comma. Okay, so we do see we have numbers here now. But these are cumulative numbers, not daily numbers, okay? But let's go ahead and do let's go ahead and do a plot of cumulative cases. So what we have to do is we need to calculate. Let's just, I really want to do this. Okay, so what we need to do here is, let's try this. Okay, now if that worked correctly, okay, why isn't this? SC's still not right. Somewhere I did something wrong. Okay. Now, let's do this here one row at a time. Okay, that's good. We got sweet. Now let's do this. Oh, there's there. Let's run this anyway. Okay, now let's do a sort. Let's run a diff. Okay, so we need to do a sequence here because this didn't work. Okay, so now we got the diff. We need to create a okay. Let's see. So, okay, 122. I'm trying to remember how I actually did it. Okay, then let's do this. As data frame. Okay, let's see how this looks now. Notice what it when you're using a sequence with dates, you have to tell it that that's a date field. So it's as date to date by 1 day at a time. Okay. So now let's come down here once again. Let's do a plot. Um, uh, oh, yes. Okay. Okay. Very good. Very, very, very good. Very, very, very good. So what we want to do is des date. Okay. Caption. Okay. So you can see we got a couple of dates here. Okay. So now let's do a smooth. nice. Very nice. Okay. Smooth equals 0.5, comma, equals. And we also want to define and let's see. All right, let's put this. Okay, so now we can see what happens here a little bit. Yeah, there is a trend up. Okay, okay, so now you can see the plot here. Come back up here and plot this. You can see a difference. Okay, this is trending up. Well, actually, they're both trending up, aren't they? Okay, there is a little bit of a downturn here, but there is a trend up here. Okay, so now what let's do is let's combine. Okay, let's do this. Let's do this up here instead first. Come all the way down to here. We got this. Let's get rid of this smooth. Oh, this would be. What we're trying to do, we're going to try to analyze, compare both data sets on one plot. Okay? It's just a matter of using two different geoline functions. Okay. Okay. So let's see what happens here. Oh, what happened? This should work here, I think. Let's try something. So that works okay. And yet, let's see. Let's try this again. Well, here's the trouble. This is okay. Let's get rid of this part here first. Oh, this should work, right? No? Okay, we got that. Let's try this. Okay. Now, what I want you to notice is how close these are up to equals. Okay. What you can see here is they're very close up onto this last stretch here. So we'll have to keep an eye on that. But overall, I'm not sure that even this difference here really makes that much difference. Let's do something. Let's do one more thing here. Let's do a first. Let's do a. Okay. All right. Let's do one more little funky thing. Let's do a low S function, shall we? So we can do this. Smooth. Okay. Okay. Okay, so now let's take a look at the low S function, which is a good way to look beyond the volatility. I'm also going to change this equals as I do often, 25, and the same thing here. Let's try these two one more time. Now you can see here, the only difference is this little line right back down here. Outside that, they're almost exactly the same. So, in my uneducated opinion, the two data sets are basically tell the same story, almost identical up until this very last part here, where you see the John Hopkins number is actually climbing up a little bit. The European number is kind of leveling out. So anyway, let's run a support from the top to see what we got here. Okay, let's turn off some. Okay, let's just do one more thing here, shall we? Let's come back down here. And again, we're only concerned with the question of deaths here. Let's let's do this. Let's just plot the cumulative. Let's just plot cumulative cases, cumulative deaths. Let's plot cumulative cases and cumulative deaths from the John Hopkins data. Okay? So, once again, X confirmed. And actually, I think this is probably a good place to actually Okay. This is kind of strange. Oh, I didn't put a. I created the cameras, but I didn't create the numbers. Okay. So now you can see Sweden's cumulative cases by date. This is no surprise. A steep upcline, then it leveled off, then now it's starting to go up again. Okay. So now let's just do the this. Now we could, of course, or not. We could, of course, calculate the cumulative totals for the European data also, but we're not. Okay. So here's his average number of cases for the European numbers. 537, average number of deaths, 19.9. You can see here the fitted curve is very fitted. It does seem to be increasing here a little bit. This is the European data. If you look at the now, if we look at the Sweden data by date from the John Hopkins data, you do see a situation. You do see this climb up here, but the trend line is still showing a little bit of an increase here. Okay, yeah, there's a 40 up here, but is this really critical enough? This could just be an anomaly. This could be this could. We have to wait till tomorrow and see what this does tomorrow. Let's come down now. Let's compare the two. On top, you see pretty much match all the way up down at the very end. Then this shows it's going down, and this shows it's going up. If we look at the curves using the lowest, just the lowest function themselves, what you can see is uh, European numbers kind of flattened out, while the John Hopkins numbers go up a little bit. Finally, let's look at the cumulative numbers. Cumulative cases going up, of course. Remember, cumulative numbers should always go up. This is interesting here. This is huge spike up. Look how it leveled off here. This is what's called. So they've really flattened the curve on deaths. Okay, they really flattened the curves on deaths. So my guess is overall Sweden is doing a phenomenal job. Phenomenal job of flattening that curve. Okay, so if you're in Sweden, I hope this was encouraging to you. If you know someone in Sweden, then please share these two videos with your friends. Share the link to your website. Put a link to the YouTube video on your Facebook or your Twitter account or whatever. Include both these videos on there for the benefit of your friends in Sweden. Our friends in Sweden. Thanks so much for the time. We'll catch you on the next report.